This presentation will discuss the reasons we think using VR technology to further enhance learning experience is better solution. This presentation is prepared by Badr al-Kendiri, Badr al-Kharji, Faisal Shudukhi, and Hamd al-Husseini.
And a special thanks to our dear friend Abdullah Shatti for sacrificing his place for the competition.
For the outline for this presentation is as following. We will introduce you with our project, problems and solutions, technical and lecture review, how we implement the project, and conclusion. How important is education in a human's life? Humans have the skills to improve themselves by education to upgrade their life. How efficient is our education system? Education systems nowadays feels outdated because it uses the old core modules. Are there ways to enhance the deliverance of information? By using the new technology in educational systems, we can improve the learning experience for the students and even the teachers. Can VR help aiding the learning experience? Yes, because the VR is interactive, and by this it will feed the students' curiosity. It's affordable. Most VR programs is cheap, and with the new VR headsets, educational organization can afford it for the department that needs it. For the common problems in learning about space is that space analogy books and slides have false distance between the planets and moon in the pictures. Why is it not accurate? It's not accurate because no book can have the accurate picture of the space because of its size. Why is it important to fix? It's important to fix to deliver the accurate information for the students. Ways to solve this problem? To solve this problem, we showed the accurate size of space and the accurate distance between planets and moons and sun in our application. As you will see in the video after this presentation, you can see that the player can interactive with the buttons in the hub to travel to the planets of the solar system. It will have a UI to show the information of the planets and the stars so the student can benefit from the application. We implemented some physics equation for the gravity in space plus the rotation of the planets. For lecture review, we have three main points, which is motivation, affordability, advantages. For the first point, the application will boost the motivation for the students to learn more of
Astronomy.
The application will expose the students to a new technology, which is different from their classical way of learning. It will feed their curiosity more and will keep them interested. For the second point, we have affordability. It might be a bit expensive, but in our opinion, it will be a good investment for the future. It is usable as long as the students have a supervision over them to secure their safety. The application will save the teachers some time from preparing for the subject because they will not go and make core modular for the subject. For the last part, we have the advantages of the VR. In the educational system, it will let the students to see from their point of view and be in the shoes of the scientist that discovered the topic. VR can prevent some dangerous situation by building some training camp by the VR, like a training camp for the army or firefighters or astronauts. It will prevent them from the danger of the training.
In our game, we have implemented real physical equations and real data in order to enhance the game experience. For the physics equations, we have coded Newton's law of gravity, which governs the behavior of two objects or more attracting each other. Another physics equations we included is Rayleigh scattering, which basically simulates how light gets scattered in the atmosphere depending on the index of scattering, which is caused by the type of molecules in the air and the light source. For the real data, we made sure to keep the distance and sizes as close to reality as possible to give the user that feeling of how big space actually is. The data included in the application is distance between planets and moons, the mass of the objects, orbital and rotational speed, and planetary textures. For the implementation, we have used C# as a coding language since Unity uses C# in order to compile codes. We used Cinema 4D and Blender in order to model the planets and some other objects and prefabs. We used Photoshop and GIMP in order to generate other textures like normal maps and other texture related things. We used Unity game engine since it is more customizable in terms of coding and blueprint scripting, so it was the game engine of choice. Our project resources are composed of science libraries, books, planetary images from space agencies like NASA, custom and pre-made C# scripts, shaders based on Rayleigh scattering, custom and pre-made 3D objects. To conclude, our project aim is to allow people to fix their false ideas about space, teaching a valuable lesson that you should always believe what you see with your own eyes, not what you hear, and building the love for adventure and discovery.